Hello friends, in today's class we are going to talk about file allocation method on disk. Welcome here, and we are talking about this file allocation method on disk. And as the name suggests, the allocation method defines how the files are stored in the disk blocks. Okay, so how the files are going to store in the disk block. And there are three main disk space or file allocation methods are there. One is your contiguous, second is your linked, and third is your indexed allocation. Okay, so what we are talking about is that how a file is going to store in the disk block. Okay, and that is defined by this three different method. Now when we are allocating this file on the disk, then there must be a few criteria that must be satisfied. That the first is that we must be able to access them easily, or access them in a faster access, we can say. Okay, so faster access is the one criteria, and then it must utilize this entire storage very efficiently, right? So that storage should be utilized in efficient way, right? So that is the 2 point over here, that the main idea behind this method to provide that contiguous or linked or indexed is the efficient disk space utilization, right? So we want to utilize it better. And the second is the faster access to the file of the blocks. Okay, all three methods have their own advantage and disadvantages discussed below. Okay, so now we're going to discuss what are the corresponding, how the method works, and what are the corresponding advantages and disadvantages. So among this, the first allocation is the contiguous, and that, as the name suggests, that file is allocated in a contiguous disk block. Okay, contiguous disk block. Contiguous disk blocks. Okay, contiguous disk blocks are being allocated. Okay, contiguous disk blocks are being allocated in this method. Okay, so as the name suggests, that each file occupies a set of contiguous block. Okay, and best performance in most cases, if you are allocating the disk block, allocating a file a consecutive disk address, then that will give you the best performance. Reason is that each block sequential can be accessed. Each block access required one seek and rotational latency. Okay, so in 1 second rotational latency, we can get our this we can position our head into the beginning, and then we can read the entire file into this. Okay, so that's why it is saying the best performance. Simple, only the starting location and the length are required, and problems may be there, including the finding the space, whether that much space is available or not for a file. And then in contiguous allocation, we have seen the first fit, best fit, and next fit method, and these are we have seen in memory management: main memory, first fit, best fit, and next fit, and worst fit. So we have seen all these methods, and that is also here in this case, that problem including finding space for the file, knowing the file size, and external fragmentation, and need compaction offline, downtime, or online. Okay, but this online operation will be very costly, that if the system is not busy, then we can do the compaction, and it's a costly operation because disks are slow actually. Okay, disks are slow. So even we have commented something like this, that compaction is not possible because of the slowness of the disk. So here in this we have a mapping from logical to physical, that we have a file size, the file name count, and that start from 0 and length is 2. So start from 0, length is 2. So this is 0th block, first block. TR is the file that start from 14 and is having length 3. So 14, 15, 16 occupied. Mail is the file that start from 19 and having a length of 6. So 19, 19 and 6. Okay, so 19, 20, 21, 22, 23 and 24 all are occupied. Okay, so this is a contiguous allocation method, and this is how it has been implemented, and this is my directory in that case. Okay, coming back here, both sequential and direct access. I can go for the sequential as well as the direct access are supported by this. For the direct access, the kth block, I can, like here in this case, you want to direct access, you can go to the directly to the 0th block, start of 0, and then you can directly access it from here. You can directly, for F file, you can directly go to 6 and directly access it from here. Now for sequential and direct, this is for sequential access. I'm sorry for this. This is for sequential access. For direct access, what you can do, the kth block that you want to access for the file, then it can be easily obtained by B plus K, the starting address plus 4th block. Okay, so 4th block can be obtained by, like here, the first block can be obtained by plus 0, and first block can be obtained by plus 1, second block. Okay, so that way kth block can be obtained here in this case, though written B plus K, but we can obtain it. Plus minus is okay, and that is actually depend upon the implementation, that will be plus or minus. But here you can obtain here, suppose there is a 19 and 19th block, then you want the 4th block, the 23. Okay, so 19 plus 4, that you go to the 23rd block. Okay, so that is your kth block can be obtained. This is extremely fast, and since the number of seeks are minimal because of contiguous allocation of the block. Okay, so that is the reason I told you earlier that it is a very quite faster access. Okay, so here that is the reason that it is one of the fastest method, and really less time it will take. Disadvantages will come from in terms of internal as well as external fragmentation. That means we have enough space with us, but not contiguous, Okay, and that is here, and that leads to the inefficient in terms of memory utilization. And suppose we are adding the file here in this case, and increasing the file size may be difficult. Okay, depends upon the availability of contiguous memory in a particular instance. Okay, so files are keep modifying, but here in this case it may be difficult, to increase the file size. The next is your linked allocation method, and here in the linked, as the name suggests, that we have a linked list in this case. Linked list of what? Linked list will be maintained for blocks. Okay, linked list will be maintained for the blocks allocated for the file. Okay, allocated for file. Now that, okay, so a few properties, that each file a linked list of blocks. File ends with a nil pointer, no external fragmentation, right? So it can be randomly scattered. Your file can be randomly scattered in disk, and that is giving you advantage in terms of utilization, but there will be some disadvantage associated with this. Okay, each block pointer point to a new block, no compaction and external fragmentation. You can see that this is one of the key point of linked allocation. Now, free space management system called when a new block is needed. Okay, and improve the efficiency by clustering blocks into groups and increases the internal fragmentation. That is okay. Internal fragmentation, the reliability can be a problem. This point is about if there is something, the link is broken or it is crashed or some That is the idea here in this case. And locating a block may take a many IO and disk sake. Okay, so the main thing here in this case is the random access. Okay, like here direct access, direct means direct access and sequential access both possible. Here sequential access is possible, random access is possible. That required but a lot of seek, and for each file, if you're even the sequential access is not possible in this case. The sequential access will not be possible in this case. Okay, now so each file has a linked list of the disk block, and block may be scattered anywhere in the disk. So there is a block and there will be a pointer value in this. So like the file name is here Jeep and start from 9, and from 9 to 1, 9 is having a list entry as 9 to 1. Okay, 1 2 then when we are going to this 1 2 we are going to 2. Okay, 9 is saying 1 2 2 2. Okay, entries are like this only here in this case is 9 to I think it is. Okay, if it is 1 then we need to go, but the point here in this case is it is 16. Okay, it's pointing to 16, 16 is pointing to 1, 1 is pointing to 2. Okay, the block number is 2. Okay, fine. So it is pointing to 16 this block, and then it is pointing to this block number 1, then block number 6, then block number 10, and then it is pointing to block number 25, and end is the 25 which is having -1. Okay, so -1 is written here in this case, and that -1 is your ending of the block. I feel that there is something that is missing here, I guess. 9, but this is a pointer pointing to this this number, and that should be, I think 16 should be the correct one, and 1 should be here, I guess. Or this does not have any meaning. Maybe let's have, but this it's a linked list. Okay, so that way it has been maintained here in this case. Okay, but the entry, if the entry is the 25th block is the entry, and that entry will be here in this case will be -1. Advantage is very flexible in terms of file size. File can be increased easily, and system does not look into the contiguous chunk of memory, and there will be does not suffer from the external fragmentation. Okay, I'll still thinking that this figure is taken, I think somewhere down the line. I feel that figure is not entirely correct, but anyway, here, because we have a understanding of the giving the address here, so it could have been much better that if I write here in this case is but these are the values. I don't think that it represent it anyway, but there is a linked list, there is a pointer that is pointing to this block, then this block, then this block, then this block, directly to -1, and if it is content is -1, okay, then it is -1, then it is the end, or let's say the last block. Okay, next, so I already told you that very flexible in terms of file size, and it can be increased very easily, and really because we don't leak the contiguous chunk of memory. This method does not suffer from the external fragmentation. Fragmentation will not occur because the linked nature of it. There is lots of disadvantage here, and one of the disadvantage is the random access. Okay, and random access, and it incurs a lot of IO. Okay, because the file size is distributed randomly on the disk, a large number of seeks are needed across every block individually. Okay, so for every block, and we are supposed to access every block, and that requires large amount of the IO, and that will definitely it will be slower in the nature. Okay, it will be really slower in the nature. It does not support random access of the direct access. We cannot directly go to the access the block of the file. Okay, block K of the file can be accessed by the traversing the K block sequentially. You have to follow the link in this case. Okay, so now I cannot go directly over here. I cannot go, suppose I have to access this fourth block, then I cannot go directly over here. I have to traverse this entire list, to to get to this particular block. Okay, and from the starting of the block via the block pointer. Now pointers, if you're maintaining the pointer, then it is really an extra overhead. So that is a really disadvantage. There is a slower and it does not support the random access, and it is having extra overhead. File allocation table comes into the rescue for this, and that the main disadvantage that random access of a particular block is not provided. In order to access the block, we need to access all its previous block. Okay, so that is one of the key disadvantage of this. And file allocation table overcome this drawback of the linked list allocation. Okay, so what we do is, rather than following the block, we maintain a file. Okay, a file allocation table is maintained which gathers all the disk block links. So now we maintain all the disk block link, and the table has one entry for each disk block and indexed by the block number. Okay, so we are maintaining a special table so that at least it give me the random access for each block. So something like this, that this is the directory entry, and this is the 207, then it will contain 618, then I can go to 618, that is saying 399, then I can go to 399, and finally if it is -1, then we'll stop. This is what your file allocation table linked access, and in that we are gathering all the block indexes. This is another one, that suppose the start block is 4 to 10, go to the 10 block, it is say 1, go to the block number 1, it says 3, go to the block 3 says -1, so we'll stop here. Okay, so that is another diagram for this file allocation table. This table has to be cached. Okay, and in order to reduce the number of head sig, you have to first cache this table, and cache means you have to put into the buffer somewhere that you can directly access. Now the head doesn't now with this head doesn't need to traverse all the disk block in order to access successive block. Okay, in a simple access of the file allocation table, read the desired block entry from the access of the block. It simply access the file allocation table, read the desired block entry from there, and access the block. This is the way by which the random access is accomplished by FAT. So you first access the file table, read the desired entry that you want to read, take the block number, and just read it out. MS-DOS and pre-NT Windows version uses this one. So key point is the beginning of the volume has a table indexed by the block number, much like a linked list, but faster on the disk and cacheable, and new block allocation is simple. Okay, this is the key point for some FAT, file allocation table. Okay, so the last one here in this case is the indexed file allocation, indexed allocation. Okay, so now we are going to maintain the index. A special block that is called the index block contains the pointer to all the block that occupies the files. Okay, so now it's like more like file allocation table, but rather than pointing to blocks here, we are directly having address of the block. Okay, so index and linked with FAT are more or less have a same idea here in this cases, that we are having a file, index file, and that contains the block. Each file has its own index block. Okay, the ith entry of the index block contains the disk address of the ith file block. Okay, and the directory entry contains the address of the index block shown in the image. Okay, so this is the index, and it is now containing the file address, block for block number 0 for the file, 1 for the file, 2 for the file. So now we have this file zip and 19, and now we have this indexes over here. So this is the index that it is first pointing to the 9th one. Okay, so there is an index of 9, and then we have an index of 16. Then we have a 1 index of 1, then we have an index of 10 with us, then we have a 25, and then rest of them is -1. So what does it contain? Your files it contains. Then the same thing is external fragmentation will be definitely going to reduce, but what about the random access? Okay, so we need the index table. Random access is possible because we can search the index. Okay, we can search the index and take the entry and directly go to this, and we also reduce the external fragmentation. Okay, so more or less a very good method of maintaining the index. Advantages is direct access, sequential access. We can do this, but anyway, the fastest, it will not be fastest because scattering is there, and the moment scattering will be there, then it will be not the one of the fastest method, but it will become the slowest one. Overcomes external fragmentation, but it will not fast. And the fastest method will be what? The fastest method will still be your first one, that is your contiguous. Okay, and though there are several disadvantages, the method will be fastest in this. Pointer overhead is there, and for index allocation greater than the linked allocation, because we are maintaining each, for everyone we are maintaining the pointer in this case. For a small, very small file that expand to 2-3 blocks, index allocation will keep the entire block for the pointer, which is inefficient in terms of the memory utilization. Okay, so even if there are 2 or 3 blocks are allocated, one index file will consume the entire block. Okay, so that is the 3 different methods of allocation, and we have seen that advantages and disadvantages of each allocation. Okay, so this is the idea over here, and this is the simple different ways you can allocate the file here in this case. Okay, in the next section we will talk about we'll extend our discussion of indexed allocation. Okay, and that we will see that what happens if the file size is very large, we have to maintain a inode structure. Okay, so the next topic is the inode. So that's all for this section. Thank you.